Okay, go ahead. You are live on YouTube.
Perfect. Thanks for having me. My name is Henrik. I work at CSC, and I'll be presenting a very brief overview of the upcoming EuroHPC Federation platform, where now, for example, Easy will play a significant part in delivering the solution. So just an insanely short recap for those who do not know. So the EuroHPC JU is, let's say, an entity which funds the European HPC ecosystem, and they own a bunch of now supercomputers which have been co-funded by various consortiums or countries within Europe. Mare Nostrum 5, Leonardo, or Lumi supercomputer, you might have heard of some of those earlier. Now, the current challenges with the ecosystem, oh, sorry, wrong slide. So what are we going to federate? Or what is the EuroHPC going to federate? It is the current, let's say, classical supercomputers, which of most are operational, or some are becoming operational very soon. For example, Jupiter at JSC. Then there will be these so-called AI factories, HPC systems, more geared or designed for AI workloads. And then as an additional set of systems, the quantum computers, which are also being procured in various places around Europe. Now, the current issues that users face when using the EuroHPC supercomputers are several. Currently, end users acquire fully separate accounts and projects or allocations through completely different processes and portals for each systems. This also means that steps like initial user identification, password rotations, any kind of credential management is always redone for each individual system. Now there's 9 of them, soon there'll be 12, and there's 13 AI factors, so we're speaking about plus 20 systems easily. Then there is a increasing number of new user groups which would like to benefit from the compute capability offered by the kind of HPC ecosystem, but which are not super familiar with, let's say, classical supercomputing or even computing in general, or they use a different set of tool instead of just SSHing in and working on the command line. AI here is one of the prime examples, and certain types of industry users are another very common user group. As we know, the heterogeneity of both compute hardware environment is growing. The variety on accelerators, frameworks is increasing, making it a larger job to transition between the various different systems. And last but not least, I mean, compute is much easier to move than data. So to answer this, we are building a federation platform with the main goal being the federation of all current and future EuroHPC systems, with the main features here being a federated identity and single sign-on. This essentially just means that a user would be able to use their usually university or home institution provided authentication credential to authenticate to any service or system part of the EuroHPC ecosystem. We're also going to provide a single point for resource management and monitoring and user management across the systems, so that end users and scientists having access to multiple systems can manage those allocations and memberships in a single place, instead of, again, having to go to 15 different portals. To homogenize, let's say, the low-level or direct access, we will be providing certificate-based SSH access to all the EuroHPC systems, with some additional features like MFA baked in for additional security. Now, these are the kind of 3 pillars for the federation, which then everything else builds on top of: identity, allocations, and access. To address then the needs of other user groups, what we will be building is higher level functionality, those being mainly interactive web-based usage for remote desktops, shell sessions, or Jupyter notebooks running directly in the user's browser. And probably the main interest for this group, and I have some more weight towards the end on discussions around this. So the federated software catalog. So with the vision being in providing a pre-installed pseudo-uniform software stack across all the systems to level the playing fields and ease either the transition between the systems or the usage of multiple systems in some sort of complex workflows. And then, of course, to support this, advanced functionality for orchestrating workflows either on a single system or across multiple systems with the associated data transfer needs. This is a rather long project. It is a 5-year project with the first, let's say, minimum viable product becoming operational by the start of next year or end of March 26. And this is a consortium delivering this service to the EuroHPC JU, which is led by CSC, and then with the partners being Giant, IT4I, University of Tartu, Ghent University, and Nordunet. So the basic idea is there is a central platform with various, let's say, function-specific user interfaces, which are then integrated to the various hosting entities, or in this case, I mean the HPC systems. So there is one component responsible for handling allocations, one for interactive computing, and one for providing the federated software stack. And in the design, we've really heavily leaned into this being very modular, flexible, and being as non-intrusive as possible. We are not trying to tell any, let's say, participating sites exactly how they should do things, or that they should install some very high privileged components. So essentially all the major components in these solutions are based on open source technologies. I'm showing the logos here. Most or some of them might be familiar. And then here, I mean, prominently shown EasyBuild and CVMFS. So as I previously touched, the grand idea, there is a platform with web and API access, which users can connect to and then manage their allocations, launch workflows, do interactive usage. The federation platform is then connected to all the various systems via some very lightweight integration, but the user always has the option to directly access the system, still using their federated identity, so that they're not required or forced to use the higher level functionality we're providing. This is simply a value add-on. Briefly flashing the main open source components. So the AAI is going to leverage MyXID. The allocation management is going to be based on Waldorf, for which there is a separate presentation. For interactive, we're using Open On Demand. Workflows is based on the Lexis platform, for which I think there is also a separate presentation. And then, of course, the federated software catalog will be based mostly on EasyBuild with Easy, and then delivered via CVMFS whenever possible. And most of these, I mean, they exist. You probably know them. You can test them out. So simply put, the federated identity is an AAI proxy plus a discovery service plus an account registry. From the user point of perspective, you will simply be able to select your home institution from, I think we have around 8,000 identity provider, and then just authenticate that one. And the AAI also provides this SSH certificate authority for direct access to the systems. there's a separate presentation for this, but in short, a unified portal for managing project who are in those projects and what compute allocations do these projects have access to, be that HPC, cloud-like features, quantum features, or whatever the EuroHPC JU will decide to offer to its users. Also, then for the workflows, the idea is to provide a high-level interface to visually manage workflow and the distributed data management across the federated resources. It is not just going to be point and click. There are APIs for power users who want to integrate their existing solutions to this one. Integrated into the workflows and also as a standalone feature, there will be a, let's say, a smart scheduling capacity, which, let's say, in the first version simply means that a user or a workflow system can ask the question that, where should I schedule if I am in a hurry, i.e., where is the shortest queue out of all the federated systems? So that's something we're hopefully aiming to achieve. And the workflow based on Lexis, again, separate presentation, so I won't dig too deep into this one, but that is then using kind of this hippie middleware for restricted access to HPC infrastructure. Interactive computing, so I mean, really nice for new users or industry users. The idea being that graphical or interactive applications like Jupyter notebooks or similar software can be started automatically by the user and just accessed through their web browser. Then with some additional functionality of getting shell access and getting, let's say, direct file access to the HPC systems. For those who know Open On Demand, it could be pointed out that we will not be merely deploying the stock Open On Demand. CSC will be contributing a fairly large feature enhancement so that Open On Demand can be moved further away from the system. So there will be one Open On Demand with access to all the EuroHPC systems. Okay, and now I'm into the most interesting part for this audience. So the software catalog.
Left, Henrik, 5 minutes left.
Yes. So the federated software catalog is will be based on ASI. With then additional discoverability features, both for users to browse what software is available where, and then for the other interfaces to be able to automatically show the user a list of available software when they want to execute somewhere. Ideally, these would be distributed via native CVMFS installations for best performance. This is not always possible based on constraints from the federated systems, and there we have multiple different workarounds so that it can still be enabled. And I would really like to stress that, of course, I mean, this is not a silver bullet which would serve every use case and every possible person doing the HPC on the EuroHPC systems. This is not meant to replace the great work sites are already doing in providing their own software stack. This is more a baseline which is the same across the system, which can be used as an alternative or in, let's say, conjunction with the existing software stack. And there the kind of guiding principle is enabling a scalability of supporting the users and how well they can self-service then install more things. Of course, I mean, our project cannot do installation requests for every single user in Europe. That wouldn't scale, but with the vision being that ASI provides the base stack, and you can, for example, then using EasyBuild, extend that to your heart's content, preferably, I mean, very easily, so that it works across multiple systems. with the end goal, of course, being that we save time for users, and then not all sites can provide very large collections of pre-installed software. So we hope there that this can kind of bridge that gap for the users requiring some more special things. And of course, I'm hoping that it will then kind of lower the bar for people to contribute to both Easy and EasyBuild if it's then much more readily available on a very large amount of systems. So this is final last slide. So just to comment my ASE wish list, which I think most of these are being worked on. Otherwise, please correct me. Robust GPU support for both AMD and NVIDIA. Support for accelerated visualization via, well, preferably EGL, and then Slingshot support, which I know there is a ticket on. And then, I mean, future discussions, I'm very open to ideas. Is now, of course, I mean, now we're targeting classical HPC systems, but EuroHPC systems will include more cloud-like features or quantum software stacks. So then the kind of best way to leverage the existing ecosystem for OpenStack IaaS or Kubernetes or anything of those, I mean, very interested in that. If you will need more information about the JU, you can go to their homepage, or you can check out the press release for the Federation platform, or then send me a message. Perfect. Thanks. Questions?
Thank you, Henrik. Any questions? York. Any questions online, Simon?
Thanks for a very interesting talk. One of the slides you mentioned data, workflow, and all of that. And I've noticed, yeah, no,
it was this one.
That one, exactly. As you've got iWords in it, and in light of AI, do you do any kind of automated metadata collection, like who submitted the job, where was it running, what program was being used, what version, you know, all of the things you automatically can collect, because that would be quite interesting for AI, where you need the metadata. Otherwise, we are generating heaps of data we never will be able to find.
Yes. So in the, let's say, the first iteration, the data movement is mostly about making sure the data is available where it is needed for compute. So there is not a huge amount of metadata support. It's more that my workflow or computation will need that data, then is it on another HPC system or in an attached cloud storage to that HPC system? Please go and fetch it. Then if there is metadata available that can be utilized, not mentioned, but this will be interoperable with Simple, which is a middleware for the kind of data federation. So if Simple provides then tooling for doing that kind of metadata discovery, then yes, we could work with that.
There's a question
slightly to the left.
Oh, sorry. There's a question in the chat as well. What are the expected advantages of Kubernetes? If there are.
Okay, so I mean, specifically from my point of view, I mean, we federate the computational resources which are there, so we do not. We are agnostic to what then the EuroHPC system decides to build. So this is more my personal feeling. The Kubernetes is maybe more relevant for certain type of industry workloads which want to have a higher degree of isolation than which is possible on most HPC systems, and then certain user groups just built all their things to work with Kubernetes, and now it's kind of hard for them to transition to purely batch-based computing. That would be my kind of 5 cents there.
Any other questions? Maybe one last one. Yeah, that seems to have answered the question. Okay, we'll wrap up here. Henrik, we're doing perfect on time. Thank you very much. And next presentation is by Martin, who has lined up. Yeah.
Hello?
Martin, you can go ahead and share the slides
Okay.
already, and we'll give you